So moving on to the third bit, which is x power 4 plus 3x cube plus 3x square plus x plus 1. So I can write p of x is equal to x power 4 plus 3x cube plus 3x square plus x plus 1. So by using the factor theorem, we can find x plus 1 is the factor of the given polynomial or not. So x plus 1 is equal to 0 and x is equal to minus 1 is the 0 of the given polynomial. So we can substitute p of minus 1 is equal to minus 1 whole power 4 plus 3 times of minus 1 cube plus 3 times of minus 1 square plus of minus 1 plus 1. This gives 1 plus 3 times of minus 1 plus 3 times of plus 1 minus 1 plus 1. Minus 1 and plus 1 gets cancelled. This gives 1 minus 3 plus 3. Minus 3 and plus 3 cancel and this gives 1, which is not equal to 0. P of minus 1 is not equal to 0. Therefore, x plus 1 is not a factor of the given polynomial. Coming to the fourth bit, which is p of x is equal to x cube minus x square minus 2 plus root 2 times of x plus root 2. So the 0 of the polynomial would become x is equal to minus 1. So substituting x is equal to minus 1 in the given polynomial, we will be getting minus 1 whole cube minus minus 1 whole square minus 2 plus root 2 times of minus 1 plus root 2. So this becomes minus 1 minus 1 plus 2 plus root 2 plus root 2. We'll be getting minus 2 plus 2 plus root 2 plus root 2. Minus 2 and plus 2 gets cancelled. Root 2 plus root 2 is 2 root 2, which is not equal to 0. Therefore, by factor theorem, we can say that x plus 1 is not a factor of the given polynomial. Coming to the first problem, determine which of the following polynomials has x plus 1 a factor. The first polynomial given to us is x cube plus x square plus x plus 1, and the second polynomial is x power 4 plus x cube plus x square plus x plus 1. So in order to find the solution of this problem, we need to make use of factor theorem. So the factor theorem states that if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. So this is the factor theorem. By using this factor theorem, let us determine x plus 1 is a factor of the given polynomials or not. So the first polynomial is given as x cube plus x square plus x plus 1. So we can write it as p of x is equal to x cube plus x square plus x plus 1. And the given linear polynomial is x plus 1. So first equate the given linear polynomial x plus 1 is equal to 0. So we get x is equal to minus 1, which is a 0 of the polynomial. Now let us substitute minus 1 in the place of x. We get p of minus 1 is equal to minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So we get minus 1 whole cube is minus 1 and minus 1 whole square is 1. This is minus 1 plus 1 which gives 0. That becomes P of minus 1 is equal to 0. By our factor theorem, we can say that x plus 1 is a factor of the polynomial x cube plus x square plus x plus 1. Now coming to the second problem, which is x power 4 plus x cube plus x square plus x plus 1. We can write it as P of x is equal to the given polynomial x power 4 plus x cube plus x square plus x plus 1. And the 0 of the polynomial we have obtained it already by x plus 1 is equal to 0 and x is equal to minus 1. So let us substitute x is equal to minus 1. That is P of minus 1 is equal to minus 1 power 4 plus minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. This gives 1 minus 1 plus 1 minus 1 plus 1. So this gives plus 1 and minus 1 gets cancelled, minus 1 and plus 1 gets cancelled. Finally we will be getting plus 1. So P of minus 1 is equal to 1, which is not equal to 0. Therefore, by factor theorem, we can say that x plus 1 is not a factor, since P of minus 1 is not equal to 0. Coming to the second problem, use the factor theorem to determine whether g of x is a factor of P of x in each of the following cases. We have been given three polynomials. P of x is equal to 2x cube plus x square minus 2x minus 1 and g of x is equal to x plus 1. And the second polynomial is P of x is equal to x cube plus 3x square plus 3x plus 1 and g of x is equal to x plus 2. The third one is P of x is equal to x cube minus 4x square plus x plus 6 and g of x is equal to x minus 3. So let us first state what is factor theorem. So the factor theorem states that if P of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of P of x if and only if P of a is equal to 0. So let us find the 0 of the polynomials, and hence if we show P of a is equal to 0, then x minus a will be the factor of the given polynomial P of x. So the first polynomial given as P of x is equal to 2x cube plus x square minus 2x minus 1, and the other one is g of x is equal to x plus 1. So first let us find the 0 of the polynomial. It is obtained by equating g of x is equal to 0, which gives x plus 1 is equal to 0, which is x is equal to minus 1. So let us substitute minus 1 in the place of x, which gives P of minus 1 is equal to 2 times of minus 1 cube plus minus 1 square minus 2 times of minus 1 minus 1, which gives 2 times of minus 1 plus 1 plus 2 minus 1, which is equal to, this is equal to minus 2 plus 1 plus 2 minus 1. Minus 2 and plus 2 gets cancelled. 1 and minus 1 also gets cancelled, which becomes 0. Therefore, P of minus 1 is equal to 0. We can say that x plus 1 is the factor of the given polynomial P of x, which is 2x cube plus x square minus 2x minus 1. Now the second one is let us use factor theorem here also. First find the 0 of the polynomial. It is x plus 2 is equal to 0, which is x is equal to minus 2. Substituting the value of minus 2 in the given polynomial, we get P of minus 2 is equal to minus 2 whole cube plus 3 times of minus 2 whole square plus 3 times of minus 2 plus 1. Minus 2 whole cube is minus 8 plus 3 times of minus 2 whole square is 4 minus 6 plus 1. This is equal to minus 8 plus 12 minus 6 plus 1. This is equal to minus 14 plus 13, which is minus 1, which is not equal to 0. Therefore, by factor theorem, we can say that g of x, which is x plus 2, is not a factor of the given polynomial P of x. Coming to the third one, which is P of x is equal to x cube minus 4x square plus x plus 6, and g of x is equal to x minus 3. First find the 0 of the polynomial by equating g of x to 0. We get x minus 3 is equal to 0, which is x is equal to 3. On substituting x is equal to 3 in the given polynomial, we will be getting P of 3 is equal to 3 cube minus 4 times of 3 square plus 3 plus 6. 3 cube is 27 minus 4 times of 3 square is 9 plus 3 plus 6, which is equal to 27 minus 36 plus 3 plus 6, that is 36 minus 36, which is equal to 0. So we got P of 3 is equal to 0. By factor theorem, we can say that x minus 3 is a factor of the given polynomial P of x. Moving on to the third problem, find the value of k if x minus 1 is a factor of P of x in each of the following cases. We have been given 4 polynomials in this question. So we need to use factor theorem in order to find the value of k if x minus 1 is a factor of P of x. So let us see the solution. So first let us state what is factor theorem. It states that if P of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of P of x if and only if P of a is equal to 0. So let us make use of this theorem in finding the values of k. So the first one is P of x is equal to x square plus x plus k and the given linear polynomial is x minus 1. So let us equate this to 0. We get x is equal to 1. And substituting the value of x in the given polynomial, p of 1 is equal to 1 square plus 1 plus k. This is equal to 1 plus 1 plus k. So by our theorem, p of 1 must be equal to 0 if x minus 1 is a factor. This gives p of 1 is equal to 2 plus k is equal to 0. That implies k is equal to minus 2. So coming to the second one, which is p of x is equal to 2x square plus kx plus root 2. So x minus 1 is a factor of p of x if and only if p of 1 is equal to 0. So p of 1 is equal to 2 times of 1 square plus k times 1 plus root 2. This must be equal to 0. This is equal to 2 plus k plus root 2 is equal to 0. So we can write k is equal to minus 2 minus root 2. Therefore, the value of k is equal to minus 2 minus root 2. Coming to the third problem, which is p of x is equal to k times x square minus root 2 times x plus 1. So by factor theorem, x minus 1 is a factor of p of x if and only if p of 1 is equal to 0. Therefore, let us first find p of 1 and equate it to 0. P of 1 is found by substituting the value of 1 in place of x in the given polynomial. This becomes k times 1 square minus root 2 times 1 plus 1, which is equal to k minus root 2 plus 1. But by our factor theorem, p of 1 must be equated to 0, which gives k minus root 2 plus 1 is equal to 0. That implies k is equal to root 2 minus 1. Therefore, the value of k is equal to root 2 minus 1. Coming to the fourth bit, which is p of x is equal to kx square minus 3x plus k. So by factor theorem, x minus 1 is a factor of the given polynomial p of x if and only if p of 1 is equal to 0. So let us find p of 1 first. P of 1 is equal to, substitute the value of 1 in place of x in the given polynomial p of x. This gives k times 1 square minus 3 times 1 plus k. This is equal to k minus 3 plus k, which is 2k minus 3. According to factor theorem, p of 1 must be equated to 0. That implies 2k minus 3 is equal to 0, which gives 2k is equal to 3, that is k is equal to 3 by 2. Therefore, the value of k is equal to 3 by 2. Factorize 12x square minus 7x plus 1, 2x square plus 7x plus 3, 6x square plus 5x minus 6, and the last one 3x square minus x minus 4. So taking down the first one, which is 12x square minus 7x plus 1. So for factorizing the given polynomial, first we need two integers such that their sum must be equal to the coefficient of x, which is minus 7, and the product must be equal to 12 times 1, which is 12. So the pair of the factors for 12 are 1, 12, 2, 6, 3, 4, and in the similar way we can write down 12, 1, 6, 2 and 4, 3. So now we need the sum which is equal to minus 7, which is nothing but the coefficient of x. So we can make use of 3 and 4 for getting the sum minus 7. That is minus 3 and minus 4 is equal to minus 7. So the given polynomial 12x square minus 7x plus 1 can be written as 12x square minus of 3 plus 4 times x plus 1, which is equal to 12x square minus 3x minus 4x plus 1. So from the first term and second term, we can take 3x as common. So we get 3x times of 4x minus 1. And from the third and fourth terms, we can take minus 1 as the common term, which is minus 1 times 4x minus 1. And now we can take 4x minus 1 from here and here as common. We will be getting 4x minus 1 times 3x minus 1. Therefore, the factors of given polynomial are 4x minus 1 and 3x minus 1. So the second polynomial given to us is 2x square plus 7x plus 3. In order to factorize the given polynomial, we need two integers such that sum is equal to 7 and product is equal to 2 times 3, which is 6. Let us write the pairs of the factors for 6. So 6 can be written as 1 times 6, 2 times 3, also 6 times 1 as well as 3 times 2. So let us make use of any of the given pairs of factors for getting the sum of 7. So we can use 1 and 6 for getting the sum as 7 in the way as 1 plus 6 is equal to 7. So now the given polynomial can be written of the form 2x square plus 1 plus 6 times x plus 3. Now we will be getting 2x square plus x plus 6 times x plus 3. So from the first and second terms, we can take x as a common term. We will be getting x times 2x plus 1. And from the third and fourth terms, we can take 3 as a common. So 3 times 2x plus 1. So from here, we can take 2x plus 1 and 2x plus 1 as a common. We will be getting 2x plus 1 times x plus 3. So now the factors of the given polynomial are 2x plus 1 and x plus 3. Now moving to the third polynomial, which is 6x square plus 5x minus 6. We need two integers such that their sum is equal to 5 and the product is equal to 6 times minus 6, which is minus 36. So let us write down the pair of the factors for 36. So we can write 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. In the similar way, we can also write 36 and 1, 18 and 2, 12 and 3, 9 and 4, as well as similarly 6 and 6. So out of these pairs of factors, we can use one of the pair for getting the sum as 5. So if you can observe, we can use 9 and 4 for getting the sum of 5. As already mentioned, the product must be equal to minus 36 and the sum must be equal to 5. So we can make use of 4 and 9 to get a sum of 5 and the product as minus 36. So minus 4 plus 9 will be equal to 5 and the product of minus 4 and 9 is minus 36. So minus 4 and 9 satisfies the condition of the product as well as sum. So rewriting the polynomial as 6x square plus minus 4 plus 9 times of x minus 6, we will be getting 6x square minus 4x plus 9x minus 6. So we can take 2x as a common from the first and second terms, 2x times of 3x minus 2, and here we can take plus 3 as common, 3 times of 3x minus 2, and we can see 3x minus 2 as a common term here, 3x minus 2 times of 2x plus 3. So the factors of the given polynomial are 3x minus 2 comma 2x plus 3. Now coming to the fourth bit, which is 3x square minus x minus 4. So we need two integers such that the sum must be equal to minus 1 and the product must be equal to 3 times minus 4, which is minus 12. So first let us write down the pairs of factors for 12. So 1 and 12, 2 and 6, 3 and 4. In the similar manner, we can write 12 and 1, 6 and 2, 4 and 3. So we can make use of any of the pairs of the factors for getting a sum of minus 1 and the product as minus 12. So let us use 3 and 4 to get the sum of minus 1 and the product as minus 12. So plus 3 minus 4 is equal to minus 1. 3 multiplied by minus 4 is equal to minus 12. So the appropriate pair is 3 and minus 4. Now the given polynomial 3x square minus x minus 4 can be written as 3x square minus 4x plus 3x minus 4. So taking down x as common from first and second terms, we get x times 3x minus 4 plus, taking 1 as common from third and fourth terms, 1 times 3x minus 4. So we can find 3x minus 4 as the common. So 3x minus 4 times x plus 1. Now the required factors are 3x minus 4 and x plus 1. Coming to the fifth problem, factorize x cube minus 2x square minus x plus 2, x cube minus 3x square minus 9x minus 5, x cube plus 13x square plus 32x plus 20, 2y cube plus y square minus 2y minus 1. So let us find the solution for the first bit, which is x cube minus 2x square minus x plus 2. This is a cubic polynomial. I assume it as p of x is equal to x cube minus 2x square minus x plus 2. Here the constant term given to us is 2. So let us write down the factors for 2. The factors for 2 are plus or minus 1 and plus or minus 2. So let us check it. P of 1, P of minus 1, P of 2, P of minus 2. P of 1 is equal to 1 cube minus 2 times of 1 square minus 1 plus 2, which is 1 minus 2 minus 1 plus 2, which is equal to 1 plus 2 minus 2 minus 1, which is equal to 3 minus 3, which is 0. So we got P of 1 is equal to 0. Since P of 1 is equal to 0, by factor theorem we can say that x minus 1 is a factor of P of x. Now let us write down the given polynomial x cube minus 2x square minus x plus 2 in such a way that we take x minus 1 as a common from that. So rewriting the given polynomial, we get x cube minus x square minus x square plus x minus 2x plus 2. I've written this in this form so that we can take x minus 1 as a common from the given polynomial. Now taking x as common, we get x minus 1 as a common from the first term, and from this we can take x as a common. This is x times x minus 1, and from this we can take minus 2 as a common. So we'll be getting x minus 1 as a common. So if we observe, we can find x minus 1 as a common from the first 3 terms. So we can write it as x minus 1 times of x square minus x minus 2. So the given cubic polynomial is written of the form x minus 1 multiplied by x square minus x minus 2. This is a quadratic polynomial. So we have already known how to find the factors for a quadratic polynomial. So let us write down the factors for this polynomial x square minus x minus 2. So the given quadratic polynomial can be splitted as x square minus x minus 2. This can be written of the form x square minus 2x plus x minus 2. which is equal to, we can take x as a common from first and second term, that is x times of x minus 2, and here we can take 1 as a common, 1 times x minus 2. So taking x minus 2 as a common, we get x minus 2 times of x plus 1. So the given quadratic polynomial x square minus x minus 2 can be factorized of the form x minus 2 times of x plus 1. So the given polynomial x cube minus 2x square minus x plus 2 can be written as x minus 1 times x square minus x minus 2, and this is equal to x minus 1 times, we have already found x square minus x minus 2 as x minus 2 times of x plus 1. So rewriting this, we get x minus 2 times of x plus 1. So the final factorization is x minus 1 times x minus 2 times of x plus 1. These are the required factors of the given cubic polynomial. Coming to the second bit, which is x cube minus 3x square minus 9x minus 5. So the given polynomial can be written as p of x is equal to x cube minus 3x square minus 9x minus 5. So the constant term here is minus 5. So let us write down the factors for minus 5. The factors are plus or minus 1 and plus or minus 5. So let us first find p of 1. This is equal to 1 cube minus 3 times of 1 square minus 9 times of 1 minus 5, which is 1 minus 3 minus 9 minus 5. This is equal to 1 minus 8 minus 9, which is 1 minus 17, which is minus 16. This is not equal to 0, so we can say that x minus 1 is not a factor. So let us check p of minus 1. So p of minus 1 is equal to minus 1 whole cube minus 3 times of minus 1 whole square minus 9 times of minus 1 minus 5. This is equal to minus 1 minus 3 plus 9 and minus 5, which is minus 9 plus 9. This is equal to 0. Therefore p of minus 1 is equal to 0. By factor theorem, we can say that x plus 1 is the factor of p of x. So the given polynomial can be written as x cube minus 3x square minus 9x minus 5. So we need to write the given polynomial in such a way that we must take x plus 1 as a factor from that. So rewriting the polynomial in this way, we get x cube plus x square minus 4x square minus 4x minus 5x and minus 5. This is equal to, so from the first and second terms we can take x square as a common term and we'll be getting x square times of x plus 1. And from third and fourth term we can take minus 4x as a common, we'll be getting minus 4x times of x plus 1. From the fifth and sixth terms we can take minus 5 as a common, we'll be getting minus 5 times of x plus 1. If we observe, we can find x plus 1 as a common from all the terms. So we can take x plus 1 as a common from the whole, and we can write it as x plus 1 times of x square minus 4x minus 5. So this is a quadratic polynomial. So we need to find the factors for x square minus 4x minus 5. So this is equal to x square minus 5x plus x minus 5. This is because we need two integers such that the sum must be equal to minus 4 and the product must be equal to minus 5. So minus 5x plus x is minus 4x and the product is also minus 5 times of 1 is minus 5. So now we can take x as a common from this, which is equal to x times of x minus 5, and we can take 1 as a common, which is equal to 1 times of x minus 5. Again we can take x minus 5 as a common. We'll be getting x minus 5 times of x plus 1. So the quadratic polynomial can be factorized into x minus 5 times of x plus 1. So the given polynomial can be written as x cube minus 3x square minus 9x minus 5 is equal to x plus 1 times of x square minus 4x minus 5. We have found the factors for the quadratic polynomial as x square minus 4x minus 5 is equal to x plus 1 times x minus 5. So the given polynomial p of x can be factorized as x plus 1 times of, in place of x square minus 4x minus 5 we can write x plus 1 times x minus 5. So the given cubic polynomial can be factorized as x plus 1 times x plus 1 times x minus 5, which is x plus 1 whole square times of x minus 5.